Hey everybody, welcome back. I'm Brian Gilmore, Director of IoT and Emerging Technology at InfluxData. Today I'm joined by Balaji Palani. We're going to be talking a little bit about observability. Welcome.
Thank you, Brian. Hey everyone, my name is Balaji Palani, and I'm the Senior Director of Product Management at InfluxData.
So we said a little bit about observability. Clearly it's a huge topic. I think there's three main things we want to cover today, right? We want to cover sort of monitoring, where it started, where it's gone to, and then of course how our customers and others are using InfluxDB for monitoring. And we'll talk a little bit, I think, at the end about some use cases that are coming right from the market. So as we've seen in all these sessions, the number of use cases where folks can use InfluxDB sort of as the back-end time series data platform, it's very diverse. I think, when we're talking specifically about IT operations and monitoring, and especially about DevOps, observability, network monitoring, what do we really mean?
Great question, Brian. I want to go beyond all the hype that's available between monitoring and observability. Let me contextualize it with my own personal experience, right? At Influx, we monitor cloud, right? So we have InfluxDB Cloud, we have developers who are on call supporting that infrastructure 24/7. So let me take you back to an incident that happened. It all started with a page that one of the developers on the query team got, but that simply stated that there's a number of queries which are failing with some errors. And as is the process, this engineer opens up an incident channel. He's joined by engineers from storage, SRE, API teams, and support teams. And quickly they realize, okay, it's not any recent deploys that's really causing this. The storage team is really going into the logs. We use Graylog internally, by the way. So they go through the Graylog and try to figure out what's going on there. And the API and SRE teams are going over, okay, let's trace back, each API, the query APIs, they're trying to look into the tracing tool to really look at which tier is causing that error. Meanwhile, support team is really looking at New Relic to see externally how many customers are being impacted by this, right? So now we saw 5 different teams with 5 different tools really looking at and trying to figure out what the problem is. Ultimately, we kind of understood what the problem was, the root cause. Once we found the root cause, simple was pretty straightforward. But just getting to that part where they're getting to the root cause took a long time.
It sounds like that key to that solving that problem might be pulling together all those metrics, logs, and traces, right? Is that the thing? So can you walk us through a little bit of what, say, a metric is? I think people really sort of closely affiliate InfluxDB with metrics.
Sure. Metric is any value, right? So any field, any values that over time you want to record it, right? It could be sensors, it could be coming from your server's infrastructure, application, state changes, anything could be a metric. But you have to understand, metrics, you can only pull up so much context, which is, I think, a little bit different than all the other events and traces and so on.
Okay. Yeah, how do metrics differ from events and traces?
Metrics, like I mentioned earlier, it doesn't have a lot of context. Events and traces, they provide more contextual information. Events could be alerts that gets emitted and you capture them, or it could also could be coming from log files where you capture specific string tests and so on. So it could be unstructured, could be more structured. Traces, they are more deep, right? So trace figures out all the different layers and tiers that API is coming from and so on. So you actually could be looking at more information, more context in terms of how long the request is taking, at which layer it's taking what time and so on. The metrics, events, and traces together, they give you a complete picture of what we call as observability, getting to the root cause faster.
Nice, and I think we have a good visual here that sort of shows how it all relates. It seems to me like traces is really about condition, situation of the different services, microservices, whereas, as you said, metrics are sort of measurements of those, key components of performance, availability, things like that. Awesome. So it sounds like, with traces, metrics, and events, you're able to sort of get that full picture of what occurred in the technology, whether it's microservices or service-based.
That's right.
Awesome. So who's actually doing this?
Yeah, so let's take an example. So there are many customers who are, in fact, doing this. They're building their own observability platform on top of InfluxDB. I get reminded of Noble9. It's one of our favorite customers within InfluxData company itself. But Noble9, because they've been with us since the beginning. When they were looking for Series A funding, they actually evaluated our open source and also our cloud, quickly found that our solution really works with them.
Awesome. And what does their platform look like? How are they getting data in? What are they doing with that data?
Right. So yeah, Noble9 actually, they're all about SLOs. So SLOs, service level objectives, right? So, they try to tie SLOs with business goals and objectives for their end customers. So they have customers of their own. So with regards to data ingestion, they use their own custom agents, which has Telegraph. Telegraph is one of our agents, has 300 plus plugins, but they embedded Telegraph within their custom agents. And they ingest data from a variety of sources, Splunk, New Relic, or even Kubernetes platforms. They can scrape because Telegraph has that ability. Telegraph has all those input and output plugins. Also, it has processing plugins that can process incoming data, and it can buffer data when the API endpoint is not available to report into. It's a very powerful tool. But they use Telegraph to be embedded into their custom agents.
Gotcha. And I mean, I'm sure being aware is great, but what else are they doing? Do they need to take action, or how are they actually using that information?
Yeah, so if you look at the SLO, right? So SLOs mean, at least, they're targeting site reliability engineers, SRE. So in their language, SLOs would mean, hey, I need to know whether I'm within my error budget. I need to know all the metrics and the 95th percentile or 90th percentile. So there's a lot of math calculation that the SREs would like to see. So what Noble9 does is once the data is ingested, they have more than 1,000 tasks. A task is nothing but a Flux script, which actually runs at specific intervals. And then they take the incoming data. Maybe they run every minute or every 15 minutes, every hour. They even have 24 hours tasks running every 24 hours that actually take all that data and then calculate all these error budgets, the SLO thresholds, whether they're breaching it or not. And then whether, if they breach it, they also send out alerts.
And where do they send those alerts? I mean, we have a visual here that shows platforms like ServiceNow and PagerDuty. Is that the bulk of it?
Exactly. So what Influx does, the Flux gives you endpoints, right? So we call them alerting endpoints, but the endpoint could be a PagerDuty, or it could be a Slack channel, or it could be just simply a HTTP post. Normally, all of these alerting endpoints have some kind of HTTP post methodology to send events into. So we tap into that as well.
Gotcha. And I think we have another visual here, which is more of a sort of generic DevOps monitoring architecture. Clearly, we have access to a lot of sources that are relevant, data types. Can you talk a little bit more about the types of use cases that they're doing? Like, what are the problems they're solving by ingesting all this data, running all those tasks, and then outputting to those alerting systems?
Yeah. Noble9 is in a particular industry, they're satisfying or targeting SREs. There are a lot of other customers who are, observability is a big, giant market, right? So you can solve each specific use cases, and that's what we are seeing. We have several other companies which actually ingest data perhaps from Splunk or New Relic, at the edges, and they kind of aggregate them and they kind of do anomaly detection for their customers so that you don't have to store the ginormous amounts of logs coming in from Splunk, and that actually makes Splunk cheaper, right? So the expensing, the cost TCO of Splunk reduces because they're able to do that. That was another example, but there are a lot of other customers, like another customer does network monitoring. Again, they extract all the data using Telegraph, send it to Influx. And if you don't have Telegraph, for example, you can also use the client libraries, right? So we support many different languages. You can just within your application or your infrastructure or the sensor, you can simply add the code snippet, a few lines of code, which sends data using that client library, sends that data into InfluxDB.
Okay, awesome. Now, I've heard you mention metrics, logs, and traces, of course. We've covered the details of that, but I've also heard you bring up a number of different platforms, which, I know from previous lives, are really sort of, the perennial favorites when it comes to these traces and these logs, the non-metrics data, where we have the lead. I'm sort of curious, like, what are we doing ourselves to present something that it would allow people to move everything into one platform and allow people to use that same set of APIs to get that full sort of broad observability?
Oh, nice. Great question. Actually, this is one of my favorite topics, actually. So at InfluxData, over the past year or so, we have been developing what is called as Project IOX.
Nice.
IOX. What is it? It's nothing but a next-gen storage engine or platform, essentially, that we are building to service exactly the needs that you just mentioned,
okay.
right? So there are 4 key design principles that we thought about, or we kept in mind when we built IOX. I'm going to tell maybe the first one, and based on that, you can ask me a series of questions or not.
Okay.
So columnar data store, right? So Influx IOX is, it's basically, we chose columnar data store as a way to store the data. Why did we do that? So for example, let's take weather as an example, and you have temperature, pressure, humidity that you calculate all across the cities using sensors. You're sending it in a row-based column, in a row-based data store. You actually are storing the entire row. Yep. So, for example, if you want to do the average temperature of a Bay Area, of all the cities in Bay Area, you have to read everything, all of the rows, including all of the columns. So it's really inefficient in terms of processing, in terms of capacity, the memory used, and so on. So, but if you use a columnar data store, you can just get the temperature alone, because that's a column. You can read all of that and then easily compute the average. You can just filter out the cities that you're looking for, like the Bay Area, and just compute the averages. It's very efficient in terms of memory processing, very efficient in terms of CPU. You don't have to read the entire database for that.
Wow, that's
so
awesome.
It's really advanced in that.
Did we build that all ourselves from scratch, or?
Yes, we did. So the way we did it was we used a lot of open source and really interoperable formats. Like, for example, Apache Arrow. Apache Arrow is an in-memory format. We are using, it's at the core of all the IOX components. The ingester, the query, the compactor all know how to really talk Apache Arrow. The other way we also did was we persisted data on disk using Apache Parquet files. So how does this help? Is Apache Parquet, again, is known for column. It's really great, like a gold standard for a column format. And it has very high compression. So what does that do is a large file could be really compressed and stored in S3. So from a customer perspective, they don't need to choose a smaller retention. They can store it forever, store it in S3, pay really, really low dollars on that. It rapidly reduces your storage costs from that perspective.
Wow, that's great. Now, if we're giving people the opportunity to store these massive amounts of data, what are they going to do with it after it's stored in Parquet?
Yeah, so Apache Parquet is also interoperable, right? With a lot of the third-party tools. If you look at customers, they always love to time series data, right? So they have seasonality. They want to run through machine learning algorithms. They want to learn modeling. They want to do forecasting. And Parquet files really makes it possible, because I can, for example, use Amazon's Athena, AWS Athena, connect into S3, look at that Apache, the Parquet file, and just operate on that. So what we do is, apart from the data store, we also work with the customers, hey, what they want to do beyond the time series data store and transformation, right? They could be running machine learning, algorithms, forecasting, and so on and so forth.
Nice. I mean, knowing a little bit about data scientists and the work that they do, I think, they operate with very, very large data sets, especially when it comes to training. And I know as many sort of features as you can use to train the better. I think one of the things that people have run into with all sorts of big data platforms is concerns over cardinality and, sort of runaway cardinality. Does all of this help?
Absolutely. That's the last design principle that we also chose. We chose to eliminate cardinality limits when it comes to storing data. Everybody's familiar with cardinality, like we talked about metrics, events, and logs and traces, right? There's a lot of context, a lot of dimensions, but when you try to store the dimension or search by a dimension or group by a particular dimension, you're looking at an exploding cardinality. With IOX, what we did was we said, you know what, you don't have to worry about cardinality. The way we have architected it is it doesn't look at cardinality. It doesn't look at indexing. It looks at, there is a catalog. It looks at the catalog, and each of these queries, right? So the query can take in Postgres dialect SQL, so SQL,
Oh, wow. Nice.
and it can determine that, there's set of in-memory data from the ingesters as well as the stored Parquet files on S3 or the object store, which is it can read both of them together and then respond to the queries. So it really very, very advantageous to do real-time analytics, right? So data comes in, it's in memory. Now the query can come in at the same time. You can combine with other long-term data stored or in the cold storage, cold tier, but you can also do the hot stored data and really respond fast. So we talked about how we can take in the events logs metrics. So you can put it in a single platform and use the real-time analytic nature. The 5 teams doesn't have to look at 5 different tools, but a single tool, single platform, and really get to that same root cause really fast.
Gotcha. And you mentioned SQL. Is that the only language that they'll be able to use to do this?
So the way we have architected it is we use the Data Fusion, which is, again, an open source project that we contribute to, which has a SQL, but we also support existing Flux. Flux is great at transformations, right? Flux is a functional language. It can not only do transformations, but it can also do, for example, any action-oriented things. Like you can we talked about HTTP posts, you can send events to a certain exterior endpoint that can trigger off a whole set of orchestration workflow. So Flux is used for that. And we also support InfluxQL because InfluxQL is something that we brought in from 1.x. We don't want to leave you behind. We want it to be backwards compatible. So it's kind of a polyglot, right? So all of these languages working together with IOX.
Wow, that sounds really powerful. So let me see if I can summarize for my own sort of understanding and for our audience. So we're pulling together logs, metrics, and traces all into one platform. We're going to let people search, analyze, do their predictions, their forecasting using the InfluxDB tools they love, like InfluxQL and Flux, the APIs that they're already using for the 1.x and the 2.x programs, and then our platforms, and then we are going to deliver to them in a highly elastic, sort of cardinality, concern-free platform. Wow. So that almost to me sounds a little bit like the future of observability. I mean, is that what we're hoping for?
Yeah, absolutely. You said it much better than myself, but yeah.
Well, I just learned it from you in real time. So thank you so much to everybody for joining, and thank you to you, Balaji, for teaching me everything I needed to know. And we look forward to seeing you at the next one.
Thanks for having me.